Okay, so the recording is started and I'm starting the official presentation. So good afternoon, everyone. My name is Michel Botman. I'm the TF moderator. Today I'm going to be helping Amanda and Iain with their presentation. This presentation is titled Introduction to Coding with Amanda Deneau and Iain Brodie. This is the second episode in a series of 6 coding webinars that OTF is going to run over the next 5 weeks. It's every Thursday afternoon at 4 p.m. So they are all set for Thursdays afternoon and all will start at 4 p.m. So if you like coding and you're passionate about it, you should really reserve your Thursdays afternoon for the next 5 weeks. And I've seen a few familiar names of people that were with us already for last week's sessions. For those of you who are returning, I'm happy to see you back. And for those of you who are new to OTF Connects, I just want to welcome you all to this new session. We have 143 teachers that have registered for this session, so that's a really fantastic number, certainly considering the Zoom fatigue that we are all experiencing in the last few months. So it's a really, really great number. I can hear people coming in as I'm doing my introduction. We're already at 68 in the room, and I think we're going to get probably close to 70. So that's really a great large group. I will just ask you all not to use your microphone unless you are invited by Amanda or Iain, because otherwise it's going to be it might turn into pandemonium with so many people in the room. So let me quickly introduce Amanda and Iain. Just a quick second, sorry. So Amanda is an education consultant and teacher of all grade levels. She's passionate about STEAM and innovative learning. She's a musician, an artist, an athletic wife, mother, and coach. And Amanda has founded her own company called We STEAmed Innovations. I don't know if I'm pronouncing it well, but
you're doing well.
Okay, and it's a company that she started to teach coding, robotics, and STEAM activities to children and to adults of all ages. And so we are really delighted to have Amanda with us today. And sorry, I went a bit too far. And Iain is a long-time educator, having taught all grades from grade 1 to 8, almost exclusively in combined grades. Like Amanda, he is also a musician, so actually a classic, former classic musician. I don't know what instrument.
Guitar and lute.
Guitar and lute. Whoa, lute! Yeah, impressive.
Lute is fun.
Lute is unusual for sure.
Yeah.
And he also has a passion for teaching STEAM subject, and he has been teaching through coding since 2009. And for the moment, he's a teacher at Ontario Tech and also at Western University. And we actually have some of his students in the class, or ex-students with him, with us in the class today. So fantastic. I can see people still coming in, 74. The number is really great.
That's great.
I'm going to now pass the baton to Amanda. She will introduce the subject because I don't know anything about coding. She will introduce the subject. And then we will jump right in. So Amanda, see if you can share your screen. I'm just going to stop sharing mine.
That sounds good. I'm going to share my screen right now.
Fantastic.
Perfect. And we can see my screen, Michel?
Yes, fantastic. Perfect.
Everything is good? Good. I should hope that I see my whole screen. I don't really like to share tabs because I bounce from tab to tab, and that can get rather annoying. So thank you for the introduction. That was wonderful. I mean, I am certainly in a different age bracket, I'll say, than Iain. Every time you introduce him as retired, I go, oh, I have a long way to go. That's okay.
It's only like 20 or more years. It's fun.
Yes, you've got it. I mean, yeah. So anyway, well, thank you for that. So We have a good hour and about 10 to 15 minutes for this, and I'm going to try really hard to not use my speedy voice, but I get so excited, and there's so much to talk about when it comes to intro to coding and the new curriculum and all that, that sometimes I just kind of race through. So I'm going to try to slow her down tonight. I know that there's a lot of us in the room, which is great. I love to have an open mic forum, so as long as we can keep it so we're not interrupting one or another. If you have a question and it's just not being addressed, activate your mic and just say, hey, hang on a second, I have a question. The first thing that I'd like to do is, if you don't mind, could you please put in the chat right now your experience with coding and the students? So your comfort level. Let's say if you write 1, you're not comfortable with this at all, you're brand new, you're here to learn right from the very beginning. And let's say 5, you're as comfortable as you can be, you're here just for some tips and tricks. You're on the right path. So I'm kind of looking to see where we all stand. I'm just going to take a second and open up the chat.
Yep, it's looking. Oh wow, somebody actually has a 0. You'll
zero,
be
okay.
We're going to make that better by the end of the time.
And you know what? And I do this a lot. I've presented this many times, and sometimes I get a lot of 4 and 5s. So it allows me to show, like, where am I with my examples, because then I'll go a little deeper and further when they're 4 and 5s. So I'm going to go ahead and just assume that this is very intro. Let us code to the very intro.
It's mostly 1s and 2s. Yeah.
Yep, perfect. Okay, no problem. So we'll take care of that. Now I'm going to ask you one more thing in the chat, and then you can give your little fingers a break and sit back and relax. Would you mind now putting in the chat what grade subject you teach? And put the number, yeah, okay, 7 and 8, 6 grade. Oh, it's going fast.
Yeah, there's a whole bunch of people.
Yeah.
Kindergarten. Okay. There we go. So yeah, we've got a little bit of everybody.
I see that.
FDK, nice.
Yeah. All levels. Okay. Probably have some consultants.
Merci en français.
Oh, parfait. Some of my slides, some of my screenshots are in French, and at first I was going to translate them to in English, but I thought, nah, you know what, we're gonna keep some French in there for nos amis francophones.
Core French too.
Yeah, but the presentation will be in English. Par contre, si vous avez des questions en français, n'hésitez pas. Oui. Which means if you have questions in French, I am here, no problem. Okay, here we go. So first of all, I'm just going to go to the next slide, and we're just, Iain, if you don't mind taking away the slide number 2.
Okay, sure. So we wish to express gratitude to Mother Earth for the resources we are using, and honor all the First Nation, Métis, and Inuit people who have been living on the land since time immemorial.
And I'm going to go ahead and keep my slides non-presenter mode, and the reason is because I go back and forth quite a bit between my slides. We'll skip this guy because we got a pretty nice introduction from Michel earlier.
The nicest one we've ever had.
It was really nice. I just like that I keep using the same photo from 2017 because it keeps me youthful.
Yeah, mine was halfway through COVID, so I still didn't have like stupidly long hair.
Anywho, okay, well,
I'll stop interrupting.
At any point in time, if you guys would like to follow both Iain and I on Twitter, I'm somewhat active. I try hard to retweet a lot of things, that's for sure. But and if you ever need to reach us directly, that's a great place to find me, in the DM box on Twitter. So let's start off with talking about what is coding. We're here because we have a brand new curriculum in 2020 for math that's telling us we now need to teach little people how to code, but we don't know how to code ourselves. So let's talk about the 3 different types of coding. First of all, let's talk about coding in plain language. What does that mean? I'm going to tell you guys when buzzwords are important. So if you got a paper or a pen or a notepad or something around and I say this word's important, write it down, because those are the kind of words that you're going to probably want to use in your class. And I'm talking from JK all the way up to grade 8. You can start pseudo coding with your JKs tomorrow. And you can also be doing it with the older ones as well. Now, pseudo coding means pseudo would be like an alternate, like a fake. Okay, it's not the real actual coding language, but we're using words, symbols, or numbers, things that will allow us to follow a path. So for example, if I were to say to pseudocode to have Iain stand up, I would say, Iain, when I say go, stand up, go. And then he does it. Now, when I say go, sit down, go. And then he sits down. So that was one series of events that we used pseudocode for to give instructions. Now, if I were to do a string of this and do another sequence of events, I would then be able to say, okay, Iain, when I say go, stand up, wait 3 seconds, sit back down, go. So he stands, he waits 3 seconds, he sits. So we've now given him a number of instructions orally, and I've now directed Iain how to do this. So when you guys are learning to pseudocode, it's a great great way to start with your students to do unplugged coding activities, meaning there's no tech. You're using, maybe symbols and arrows that you've written down, you've cut out cardboard, you've thrown arrows down on a carpet that they're following different instructions. That's pseudocoding. And you can go all the way up to grade 8 level, where maybe later on you're having them write out each series of instructions of something that they want to accomplish. The next type of coding, it's kind of taking a little bridge toward the real deal, is coding through blocks. Now, I've just noticed here I'm missing a K because, this was a Français bilingual slide. So what this means is that it's genius, and it's basically taking the real context of coding, such as JavaScript or Python, the real language, and disguising them into little blocks where students can click together to create a series of events, kind of like a puzzle. That is going to be the main focus of this presentation. If you never get to the final type here, where we're saying coding with text, which is actual basic coding like Python, JavaScript, etc., it is okay. You do not have to get your students in grade 8 to be writing syntax. They will have opportunity in high school to take those classes. But what this does with the block is that it's allowing them to set their computational thinking up in a way that when it's time to go and write the real coding and programming, they are all set. I'll have you know, though, I started with a grade 7 class in January, block coding, and we don't pay too much time. We maybe a couple days a week. We have a few periods a week, and they're already at a point in time where they're ready to be writing their textual coding. And there's all kinds of resources I will show you that will allow you to go toward that. So these are the 3 different types of codings that we're going to be discussing, but the coding with the block is the main event. I'm going to let Iain take it away for computational thinking.
Okay, so computational thinking is a process that you go through in order to get your computer to do something for you. So the first thing you have to do is you have to have a problem that you need to do. So say we wanted to have somebody walk in a square. So we would have to decompose that problem. So what does it mean to actually walk in a square? Well, it means to walk forward some steps, turn 90 degrees. We would have to say which way, probably, so 90 degrees to the left, and then we would have to then repeat those sets of instructions until we get somebody to do that. Okay, so the decomposition is taking out the parts that you know you can do. What can you do? So how are we going to go about finding what are the parts to this problem? Then once we get into the parts, we'll recognize that there's a pattern. So we recognize in that square thing that we could do, there's a pattern, like we're doing 4 times, we're walking forward a certain number of steps and we're turning left 90 degrees. So now that we've got that pattern recognition, we can now put that into an abstraction, which is using the blocks. For Scratch, or the blocks for Blockly. So you would then choose the blocks that you need. I would have something that says go, because we always have to have like a go. You notice that Amanda even tells me go. If she tells go, my last program is actually stand up, wait 3 seconds, sit down. So anytime she says go, I'm gonna have to do that. It's too much power for you, Amanda. So that we get that abstraction, we put it in. So we might want to put a repeat in. So we'll have a repeat, and then we'll put in move forward so many steps, turn 90 degrees left. And then that becomes our algorithm that the computer can carry out. So the computer will now walk in a square, or our person will now walk in a square.
And the beauty of computational thinking is it's like we've heard all these buzzwords like sequential thinking and creative thinking and critical thinking. It's another type of thinking that we want to start bringing out in our young learners as early as like preschool,
Yes.
when they're on the floor with their trains and their Legos, and we're trying to find pattern recognition, and we're doing our problem solving, but before we do any problem solving, we have to do some problem identifying. So it's really a good idea to start talking to the kids early about what's going on here. We're very familiar with giving them situations and resolution, asking them to resolve problems that we give them, but maybe let's have them recognize what the problem is first. And that's where we're going to get into some really good stuff with some debugging in a little bit.
Absolutely. And then the other thing that it leads to is that once you've learned how to do this computational thinking, it helps your mathematical problem solving immensely, because you start looking at a problem, you'll break it down, you'll look for a pattern, you'll see if you can abstract it, and then you'll figure out how to solve it.
So the new math curriculum, I don't think anyone's strangers to it now, as it's been almost a year that it's been released. I'm not going to open the link and go through it, but what I did do is I opened up the overall and specific expectations while emphasizing what really kind of matters in green. The thing with this is that obviously we've planted the coding expectations in algebra, although they can be integrated in all of the math criteria. I can see where this comes in algebra. What we're trying to avoid is that teachers just take these 3 expectations, teach them, and then be done with it. Hopefully it becomes something that you integrate into all of your other subjects. So for the C3, I'm just going to read it out to you. Solve problems and create computational representations of mathematical situations using coding concepts and skills. The majority of you all don't know what that means, because I was like, what? Blah, 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 blah. It's a lot of fancy words. For basically saying we're going to have the students create computational representations. They're going to be creating algorithms in order to solve a problem. So the same old math that everybody's been doing, we're just going to use a different way of representing that situation. So the overall expectation, or the specific expectations of C3.1 and C3.2, in my opinion, are in the wrong order. Unfortunately, nobody asked my opinion when they made the math curriculum, but that's okay. But I really do believe that if I were you in a beginner spot, which I have been, is I would flip these around, because here what we're saying with C3.1 is asking that the students write and execute a code. In C3.2, we ask that they read and alter an existing code. So let's think about when you guys, when we have a newborn baby and a baby gets a little older, what are the things that we start to do with a child right away? We start doing all kinds of things right away with the child. What do you think? How about we toss in the chat? What do you guys do? What do you think? What do we do with our babies? Oh man, perfect. We got read to them, talk to them, show, model, kiss them, sing. Yes, feed, talk. Okay, I love it. We've already hit the nail on the head. So we do talk to them for sure, and we model, and we read to them. I've read to my babies right from when they could just touch a book and see the picture, feel the page. And I've never asked my baby to write their name first. So when we're asking these students to write, I'm wondering if we should flip this around and have them read different types of code that already exist, alter that code, see what happens with it, play with it. When you ask a student to open up a sandbox and start to write on their own code, it can be very daunting for both the teacher and the student, and we don't want that. We don't want it to be a stressful occasion. So I'm going to show you different ways to read and alter code and different type of programs you can use. So let me just read these specific expectations backwards to you. So read and alter existing code, including code that involves fill in the blank, and describe how changes to the code affect the outcome. Changes to the code affect the outcome. What I see here is that we want the students to read and alter a code that already exists, and then they explain what happens when we make that change. What are the effects of the outcome? And we'll get through that in a second. Now notice I've put a fill in the blank, because every grade level from grades 1 to 8, all you need to do is plunk in one new expectation for that grade that goes right here, but the instruction doesn't change. From grades 1 to 8, this is what we want. We want the students to be able to describe. This is when I start seeing, Flipgrid, Screencastify, conversation. Let's talk to our students and say, what do you see? What just happened and why? C3.1, solve problems and create computational representations of mathematical situations by writing and executing code, including code that involves fill in the blank. And every grade will have a different fill in the blank right here. We'll go through those in just 1 second. But as you can see,
for both. It's the same for both C3.1 and C3.2.
Absolutely, it's one thing. So we're going to
Yeah,
go through an infographic that's going to carry you there. I've put a little visual together on this next slide, and I kind of reorganize it the way I wanted to by saying, first of all, let's read. Let's go look at different codes that already exist. Then let's modify and see what happens. And when we see what happens, let's describe what happens out loud. And finally, let's go write our own algorithm when we get comfortable with that. So again, solve problems, read and alter, fill in the blank. Now let's go fill in those blanks. Here's a screenshot of the curriculum throughout grades 1 through 8 for coding. And we've got our C3.1 and C3.2, of course. Now I've kind of used my fancy dancy highlighter here to show you that this blah blah stays the same all the way through. Oh, this is a French one. And the things that are highlighted are the terms that you will bring out per grade. No need to squint and try to find what these says, because I have them blown up in a few seconds here. This just represents that all the way through, nothing changes except for what that person is actually expected to do in that grade.
One thing.
Yeah. Okay, so here we have a little bit of a, I guess, guideline for you to follow. Everyone's going to have the link toward this. Iain has just actually dropped it in the chat if you guys want to open that up.
Do that.
Yeah, actually, Iain, this is one toward the OAME one.
Mm-hmm.
I'm just going to go to my website. Hold on 1 second. I think I had something updated on that one.
Oh, okay.
And
yeah.
We're just going to consult the English terminology. Sorry, just a little bit laggy. Give me a second while I'm sharing my screen here. Just sharing my screen here. The OAME one is fine. I believe I had a new example, but that's okay. Either or. And so what you guys all need to do is, once you have this PDF opened, and everyone's going to have a link toward this, Michelle will have it on the website as well. I sent a PDF earlier, is that each grade is, I've made it evident on what you'll be doing per grade. If you teach grade 5, don't worry about jumping into grade 5 and going, oh dear, what do I do here? Okay, start from grade 1. We're all in this same spot. Whether you teach grade 1 or grade 8, unless you've already have experience, likely don't start in grade 1. The great thing about this is that the maturity of the students will guide you quickly. So in grade 1, we're asked to identify sequential events. And I'll show you what that looks like in just a second. In grade 2, we're asked to see what a concurrent event looks like, but you can't bypass the sequential event. So this is in addition to. So in grade 2, you're going to have the students read and alter and modify and write code that consists of sequential events and concurrent events. And in grade 3, we're going to have them read and alter and modify and describe and write code that has sequential events, concurrent events, and now repeating events. So it all keeps building from grade to grade. The maturity of the students will allow you to buzz through this quickly. For example, when I started with my grade 7s back in January, we started with the grade 1 series, and it only took a day or two in order to get to our grade 7, because their maturity says, oh, I got this, easy enough, okay, and they keep on building. Okay, so right here in the glossary, it's a bilingual glossary that I've created to help you with those buzzwords. The curriculum has a little bit. It's got their terms that are pretty important, but I think that they were missing a lot. So I went through and compiled from the ministry all of the stuff they had, and I added things that I felt that were important in your vocabulary, as well as put a French tag underneath. And if you keep scrolling down, it's actually in the middle, turns into French, and then it goes to the opposite. So if it's c'est en français, and then you can click on the English term. Okay, it's super useful. Yeah, you're right, because the immersion teachers, it's just beautiful. And sometimes you're just like, what is that in this language? And you get yourselves confused. But anyway, feel free to use this, print this. It's once you open it, it is interactive. So if you can just click, they're hyperlinked back and forth. That's in the corner of this infographic, and there's also a link toward it. So yeah, and I have a merci beaucoup in the chat. Please know that there's also a French French version of this infographic as well. Okay. Now, what we're going to do here is this might take a few minutes. I'm going to be jumping back and forth from the Scratch examples to my slides, and where I'm going to be needing to grab is actually this slide here, because we're going to bring back and shove in some terms here. So, without further ado, I'm going to click on this image right here, a screenshot of what does a sequential event look like in grade 1. I've chosen to use code.org here.
Amanda? Can
yes?
I just so for everybody, when Amanda goes to an example, I will be putting the link to that example in the chat, and you can come and do it along with her. Just so you know what those links are for. Sorry, Amanda.
No, it's all good. Thanks, Iain. I'm actually going to take the opportunity to change it into English here. I had French on default. Code.org is amazing. This is where the hour of code stems for, and the thing with code.org is if you're afraid of where to start, it builds puzzles for you from JK all the way up to the end of the curriculum and higher into secondary levels. And it's self-directed, because putting a child in a sandbox to a blank screen and saying, here, go code, it's too much. Having them start, like I said, following puzzles. So I've kind of jumped into one that would be more of a grade 1 level. There are levels, as you see, this is lesson 2. There is even before that, how to click and drag and attach blocks for JKs. I've had the kids go up in JK with, the baguette magic over to the smartboard and start learning how to click and drag. It's beautiful. All kinds of stuff for all kinds of grades. So I'm just going to continue. There's always an introduction video. And I'm only going to do a couple levels here to show you what exactly sequential events looks like. So I'm just going to click here and pay attention, because even if you teach grade 8 and you have to start from the beginning, here we are. So what we were going to do right now is we're going to read and alter existing code or solve problems, blah, 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 sequential events, grade 1. Sequential events. And a sequential event means this: to get Scrat to the acorn, snap the east block to the bottom of the when run block, then press run. How are my grade 1s going to know how to do this? They can't read. You can have them play it here, or once we get back to our days of in school, you could even have an older grade come in and do these activities with them and read with them and teach them to read. But again, you could use read and write, or you could use this to help them hear the instruction. So I'm going to say okay, and right away, even if you can't read, you can kind of decompose, do a decomposition and know that this guy's got to get to this. Got to get to this little acorn here. So what they're going to do is learn how to click, drag, and when run, he grabs his acorn. Beautiful. What is super cool with this is if you click show code, it is actually showing you the real JavaScript coding, textual coding, and the kids get super pumped to see that they've written one line of code. And if we keep going, it gets relatively more difficult as you go. So what I'm going to do now is I now need to go east and then east again. So we've created a sequential event. It is not anything more than just reading one instruction at a time. What I've told you or showed you earlier with pseudo coding is I coded Iain to stand up, wait 3 seconds, and sit down in a sequential event. It happened one step at a time. Okay, so that is what exactly grade 1s need to do. Learn how to code and give instructions one at a time. Okay, and I'll show my code. I've now written 2 lines of code, super fun. If I'm going to move quickly over to grade 2, we need to learn what sequential events are, and we're going to talk about concurrent events. So concurrent event, as you could probably infer, would be 2 instructions that happen simultaneously. En français, on dit des événements simultanés. So it's simultaneous and concurrent events. I've gone ahead and created examples for everybody. So and then the instructions, sometimes I give you guys a little bit of instructions. Click the green flag and watch the sprite start a conversation. Remix this code and add on to their chat. In grade 2, the students are asked to run concurrent codes. This means there is more than one script running at a time. In this case, when the green flag is clicked, a sound plays at the same time as the dialogue. If I wanted to remix this button here in Scratch is a beautiful button. This is where, let me go back to this presentation, it says read and alter existing code. Well, if you were to click this green button right here and start altering my code, you would be following that expectation just fine. And if you had a conversation with me or you wrote a little note or sent a little dialogue of what happened when you made those changes, you would be describing, let me go back to here, you would be describing how changes to the code affect the outcome, and you would have already met that expectation. Okay, so I'm going to go on the inside instead of remixing. I'm just going to go inside and see what does this look like. So we have, I'm going to switch it to English. Look at all the languages.
Yes, you might want to take like a moment and see all those, like, just look at that for a second, Amanda.
It's pretty cool.
This is like the best thing for a core French teacher, because now you can like go in between, and you can do the French, you can do the English. If you have an ELL student, you can have them code in their own language as they learn. Even the languages that are from right to left, the blocks are actually right to left as well. They've done a really good job here.
Yeah, so the blocks all of a sudden, poof, change into the language desired. It's definitely cool. Okay, so we've got concurrent events. Now, if I click this flag, what are you up to today? I'm not sure. What about you? Did you hear the sound? Yeah, a little bit. All right.
Yeah.
Okay, so it's okay. It was a boing and a pop. Now, what I would do to my students right now is say, okay, what is it? Why is this a concurrent event? What is going on here? And they're going to say, well, there's two codes. That's true. So if I go to my sprite right here, his name is Giga, and I've now instructed Giga that when the flag is clicked, he's going to say, hey, what are you up to today for 2 seconds? At the exact same time, when the flag is clicked, I'm going to hear a boing sound until done. Wait 2 seconds, then play a pop. And the reason I want to wait 2 seconds and play a pop is if I click on Nano, my other sprite, I've instructed him when the flag is clicked to wait 3 seconds and then say, I'm not sure, what about you, for 2 seconds. So there are 3 different things that will happen when I click this flag concurrently at the same time. So if you're in grade 2 and you're 8 years old, 7 and 8 years old, I have a daughter in grade 2, and this is a pretty easy concept for her, is that these things have to stay in this order. What would happen? Now, this is what I would do to my students and ask them a question. What would happen if we took this block and we moved it here? I'm going to ask you to either open your mic or write it in the chat, but you guys have to answer me. What would happen if I took that instruction and I plunked it underneath of my first instruction? Typically, people like to use the chat, but you're welcome to use your mics. They are now sequential. She's got it. It would happen after instead of the same time. You got it. So you are now understanding the difference between grade 1 and grade 2. And at the end of grade 2, we are hoping that the students also understand that this is not just a series of events anymore. It needs to be concurrent, happening at the same time. So if I hit play, hey, what are you up to today? Boing, wait 2 seconds. I'm not sure. What about you? Pop. I think the students would be able to explain to you, this isn't working. Now, what I say to my students, well, of course it's working, but I'm telling you, they're going to raise their hand and they're going to say, Miss, sir, my code's not working. And remember the buzzwords? You have to write this down, okay? This is important. When you answer them, you have to say, yes, your code is working exactly the way you've coded it, because the computer is going to do exactly what you've asked them to do. What they should be saying is, there's a bug in my code. There's a bug. They like to say that, and that's a true term. There's a problem somewhere. This code is doing exactly what it's asked it to do. I propose that you ask your students to try 3 different things to fix it. Ask their peers and before you give them the answer, of course. But monsieur, madame, miss, sir, my code's not working. That's forbidden. Can't say that. So train them early. No, your code's working just fine. There's a problem with your code. Okay, let's go figure that out. So then they have to decompose and try to figure out where is that problem. That's identifying the problem that I was talking about earlier. If we go and tell them what the problem is, then that's really not going to help them solve it. So of course, we just mastered that they read and altered existing code, including code that involves sequential events and concurrent events, and described how changes to the code affect the outcome. In this case, the changes to the code affected the outcome because now my sounds don't line up to my guys. It's not what I want. So I have to fix it. C3.2. I'll put you back. Moving on. Grade 3. We now need to know sequential events, concurrent events, and repeating events. Fairly simple. Here is an example in grade 3. Thank you, Iain. You're just a lovely link dropper. So good.
And commenter.
And commenter. Repeating events in grade 3. Click the flag and see Pico draw his shape. Remix the program and make a new shape on your own by using a repeat block, also known as a loop. A note, in grade 3, the students are asked to make their own code more efficient by introducing the repeat blocks. Write that down, efficient. It's a buzzword. You want their code to start to become more efficient. Yes, we could have them do sequential events forever, but eventually we need them to write the least amount of lines of code possible, because when you're busy, you've got to get your code out. So we are trying to teach them how to make the most efficient code. You can have a million different ways to write the same program, but what is the most efficient? Okay, so I'm just going to click play here and see Pico draw his triangle. Bravo. If I look inside, what does this look like? In Scratch, the awesome thing is that you can actually you can also put like little sticky notes to explain what's going on. So I've attached this note by right-clicking on the block. If I do a right-click, I can remove a comment. I already have one. So if I click here, I can add a comment and just start typing. This is my block. And an awesome thing about this is a great way to have students communicate with you. If I go back here, when we want them to read and alter an existing code and then describe how it changes the outcome, maybe you don't have an opportunity to discuss that with that student that day, or they didn't do a Flipgrid or a screencast and you haven't heard what they have had to say, but they could maybe write it here and saying, I have added this code and this is what the change has happened. And if you right click randomly, you can add a comment anywhere. So you can add instruction to your already coded program. So if I were to send this to my students and say, hi everyone, alter this code to make Pico draw a square. So they open this project, they remix the project, they've got their instruction, they know what they have to do, and then they could resubmit their project. Okay, so I'm just going to take that off. I've put a little note here for you to know that sprites turn externally. You'll need to use the external angles of your shapes. So hint, they should add up to 360 degrees. What we have here is a sequential event that this will happen all the way up until this repeat block. We've now asked Pico to go, first of all, to an X and Y coordinate. If you guys think that this is too complicated for grade 3, it's not. They understand what a coordinate is if you explain it to them early. An X goes horizontally, the Y goes vertically. You can use your arms, you can show them. They're eventually going to get it just by looking at this. Some people like to use Scratch Junior for JK up to grade 3, and I highly recommend that as well. Scratch Junior is another platform that uses iPad and Chromebook and tablet. And it has just arrows like you saw with code.org. Okay, I think that they are ready for Scratch as of grade 2. Iain will argue grade 1, and which is fine, but Scratch Junior does do the trick. So in grade 2, my daughter's age, I try to start pushing Scratch a little bit further. Okay, so Pico's going to go to this coordinate, which is lower and lower. So it's coordinate number 3. 1, 2, 3. It's down here. He's got the negative. He's got the negative. You can ask your students those things. If you project this onto your screen and say, yeah, you guys, like where would he be? Like if I put him over here, for example. Okay, where should Pico start? Is he in the right place? No. Well, how do you know that? Well, because his X is negative and his Y is negative, he's up in the right corner. He needs to be low. Okay, so let's see. I click the flag. Yep, he goes back to the bottom. We can talk about coordinates. Then I've asked him to erase everything because he might have already drawn something like he has already drawn here. I've asked him to put his pen down and set his color to yellow. We could change that to anything we wanted if you wanted to. Wait 0.5 seconds. This block that's orange is found in your control structures. These are important blocks. If something's happening and it doesn't look right and your code just isn't doing exactly what you want it to do, use the wait blocks and slow things down. Coding happens in a blink of an eye. It's invisible to the naked eye, and these blocks always solve a lot of problems. So if we put in a 0.5 wait block second, then here, like I said, we've got read and alter existing close, blah, 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 solve problems, blah, 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 with the blank. The blank in this case, if I go back to my infographic, is repeating events. The repeating events looks like this block right here. I'll grab it from the corner. him, repeats. This is called a loop. En français, c'est une boucle. So this we would plunk out right here in order to avoid 3 sequential events saying the same thing. We've made the code more efficient. That's the buzzword we're looking for, more efficient. So Pico has now been asked to move 250 steps. What does step look like in Scratch? A step is a pixel, a small little dot. So 250 looks like this. From here to there are 250 pixels. We were then going to wait 1 second, and then we're going to turn 120 degrees. And don't forget, sprites like to turn externally. Now, ask the students, maybe if you draw a circle on the board, let's say we draw a circle on the whiteboard or on our Jamboard, and we put a triangle inside that circle. It should, all the external angles should add up to 360 degrees. A trick that they can know is that if I take my repeat and I multiply that by 120, it should add up to 360. This is a nice way for them to try to figure out what my angle is. So let's say that this was a square. Okay, so now I want my students to alter this into a square. Well, I know I'm going to repeat 4 times because a square has 4 sides. This has to change. Well, what times 4 would make 360? That's when they're really going to start to play with it. Okay, what if I did 80? What does that look like? And I hit go. Well, it definitely doesn't. Okay. So they're going to laugh and they're going to say, oh, yeah. And then they're going to play with it again. Well, I'm going to try that again. Let's try 98. And then they try again. Oh boy, this is not going well for my square. It's somewhat looking like a square. And let's try 90 degrees, get to our victory. And he's actually tilted now because I didn't set him straight in my instruction. So as you know, Pico is now tilted a bit because we were having some wrong angles. All you would need to do is say, how can we get him straight again? They would have to go up to the top and fix so that he's straight. They could play with motion blocks. You know, they could stand him, they could turn him, they could point him in the direction. Actually, right here, see how he's at 98? I'm just going to plunk him up to 90 by toggling this. Without even knowing it, the students are learning their angles just by playing and drawing. Now he's straight again. Okay, so that's grade 3. Let's move on to grade 4. I don't want to save anything. Grade 4, we are going to solve problems, create writing, executing code, read and alter, change, and all that is going to happen with nested events. En français, on dit des événements imbriqués, nested events. Okay, so what does that look like? Let's click this guy. Okay, and I'm going to hit play and see what happens here. I've got Pico who's disappeared, and I've got 3 triangles. Interesting, and he's reappeared. Fun. In grade 4, the students will be required to code nested events. In this project, a control block can be put or nested into another block. So if you're feeling overwhelmed, don't. It's actually sounds harder than it really is. And if we bring that inside, let's see what we've got here. It's very similar to our past code, but what do you notice that's different this time? We can write it in the chat. You guys can open your mics, but let's, you know, predict here. What do we have? What do you see that's different this time?
A loop in a loop.
A loop in a loop. Repeating twice, yes. Well, but okay, repeating twice, but if I were to have this repeating after the repeating, it may not exactly do what I've asked it to do. It repeats inside of each other. So we've got a loop in a loop. I like that. And we have hide and we have show, because this time we wanted Pico to leave and then come back. So if I use my, you know, in sequential events here, the first thing it needs to do is go to the origin. So I've asked him to go to the center. Very easy, 0, 0. We're going to erase everything before. We're going to put our pen down and we're going to set the color to white. I've set the pen size to 4 because I want it to be a little bit thicker this time. Then I want him to hide, go away, okay? Then he's going to repeat 3 times the code that I told him to do in grade 3. If I bring this out, if you notice, this is what we talked about last time, except for him. This is the code we saw last time. And we've put him inside, we've nested so that it's going to go into this loop, do this 3 times, and do that 3 times. So 1 triangle, that's this right here. So we made a triangle. Everyone agrees that this is a triangle, and we've done it 3 different times. This block's not important, or is it? Let's say we took that block out. Do you think that block's important? If I hit play, the green flag, without this last turn 120 block that was somewhere over here, what do you predict will happen? You get 1 triangle.
2 triangles, 3 triangles on top of each other. Okay.
3 times, yeah, that, yeah.
Yep. You only see 1 triangle. Oh, this is a really, really good group.
Okay, let's see. Huh.
It actually
So,
did do the 3. You just didn't see it.
Yes, 3 triangles, one on top of each other. Now, if you notice, when I hit play, I'm going to do it again, the flag, this is yellow. It's executing, it's executing, it's executing, it's executing, and it stopped. This entire thing happened, but my problem here is that I've altered this code. So I'm going to describe how changes to the code affect the outcomes after I have read and altered an existing code. So because I took this out, my Pico drew a triangle, but he kept drawing it on top of each other. Now let's ask him to move over 120 degrees and draw the next triangle and then the next. Now, in theory, this should add up to 360 as well, because I want these triangles to be in a perfect circle. If we were to draw a circle around all 3 of these triangles, they need to be perfect. Let's see, did I do this right? Did I put the block in the right spot? Ta-da! And show. Also, I've also asked him to point into 90 degrees. Last code he tilted. So if the students were going to play with this, I'm going to alter that and make it 80 degrees. Okay. He should still in the end, even though my triangles are pretty crooked, he comes back in pointing in the proper direction. Okay. So this is good to play with. And if I wanted to alter the code with the students, say, let's do a different shape. Now this is going to get a little bit tricky. Nah, you know what? I'm going to wait for it. I'm jumping ahead. When we use Scratch, will the lessons you are showing us be available to use, or do we have to create our own lessons? The ones I'm showing you right now are in the infographic, and you guys are all going to have a link toward that. So you can use these exact ones. We're going to leave. We've now conquered grade 4. We have 2 repeats, but how come the 3 triangles? Because the second repeat actually asked it to make the triangle 3 times. Because the number 3 was in the repeat block. We could have asked it to do 10 different triangles if we wanted it to. Okay, so that is grade 4. Let's move on to grade 5. Grade 5 starts to become so much more fun. Okay, so in grade 5, the students will be using conditional statements. This means that the outcome of the program will depend on a condition. If the condition is true, the program will run a certain way. If the condition is false, it will run a different way. In this example, we have used an if-then statement. The next project will include an else statement. So in grade 5, we're concentrating on the condition if-then. I always introduce this to my grade 5s by saying, if you do your homework, then you get a reward. If you don't eat your supper, then you don't get dessert. It's what are other conditions that you guys can think of? And when I'm doing pseudo coding with this, Iain, are you ready to do the funky chicken? I'm going to pseudo code you and use a conditional statement in my pseudo coding unplugged activity. Okay, when I say go, if your birthday falls between January and March, stand up and clap your hands at the same time. Okay, ready? Go. So my condition was false. Iain did nothing. I'm going to try again, Iain. If, when I say go, if your birthday is between January and December, then stand up and clap your hands twice. Okay, so you can do fun stuff with that, even with daily physical activities. Some of my students, even in grade 7, love this because I'll say, if you like pizza, drop and do 10 push-ups. And then if we go into grade 6, you start tossing out the word else, and we'll see that in a minute. Else, do 5 sit-ups. So they're both doing something, but they have to follow the condition. Okay, let's now open, let's see what this looks like. No, I don't want to show you yet. Let's go inside. Now, I've plunked out a new little thing that's called broadcast. Broadcast is in the events here. Okay, you can play around with that. And what broadcast block means is sending a message to another sprite. And you can create your own messages. So in this scenario, I have sent it to another sprite that's called an apple. So if I click on the flag, right now you see that this is in yellow. It's playing in yellow. When you go to 0, 0, forever, this repeat block, this this control block, which is repeat forever, it means that this is happening throughout the entire game. When you start using sensors, now let me show you what a sensor looks like. This block here that's like diamond shaped plunks into a condition because it talks about true and false. And this sensor says if the Stanley is touching an apple, then play the song Chomp until done, and then broadcast a message that's called Eat Apple. Okay. If he's not, like, nothing's happening right now because he's not touching the apple. So my condition is false at this moment. I don't know if you guys are have ever heard of the mathematician George Boole. He has created the if-then statement, or the expression of true and false, on or off, yes or no. And all the Boolean, they're called Boolean expressions. And all the Boolean expressions are in diamond shapes in Scratch. So if 25 is greater than 50, then do something. So if true. Else would be false, and we'll get to that in grade 6. But right now, we're talking about true statements. So this statement is not true. Nothing's happening. I've also added concurrent coding here to say that when these arrows are pressed, we're going to change our guy, our sprite, on the axes. So we got our X and our Y, and I'm using the arrow so I can move him left and right. The kids love that because it's like their own video game now. You can also make it so it's the keys A, W, S, and E, and whatever they want to make it, just like their Minecraft stuff. Now, when it comes over here, chomp, chomp, and away goes the apple. Okay, now how did that happen? Let me click on Apple. Apple has, when I receive the message, Eat Apple. When I receive the message, Eat Apple, we have costumes in Scratch. So inside this costume, I have my apple, and then I've taken my little handy dandy eraser, and I have then made a second costume, and then a third costume. And in an animation, it starts to look like this apple has been eaten. So Stanley's not actually eating it, but it sure looks like it. So when I receive Eat Apple, switch costume to Apple 3, which is the next costume. Wait, switch to Apple 2, wait and hide. What would happen if I were to remove these wait blocks? What do you predict would happen to my animation? You got it. It would happen too quickly for me to see. It would only disappear once. So it would go from touch to this costume to hide. You won't even see it switch. It'll just skip. So these wait blocks are important. Here's another thing you can ask them. What would happen if I changed it to 1 second? Would it take me longer to eat my apple, or would I eat my apple faster? And they would say, you eat it faster, 1 second. Well, and then get into decimals. Well, 1 second, it actually means that it's going to take me a longer time to eat my apple, because 1 is a lot bigger than 0.1. Yeah, it's actually like stuck in a loop there. Okay, so it's not as favorable. So if I go back and I bring it back to my decimal, because that decimal means it's going to go a lot faster, my apple can disappear when the sprite is touching this sprite. Okay, and that is grade 5. Don't panic. It takes some practice. And don't forget that you're using the if-then block. If-then. Keep it simple. Okay, now we're moving to grade 6. Okay, in grade 6, I have made a little game, an animation game, with the conditional statements of if-else for grade 6. In grade 6, the students learn to make their code more efficient and continue with more conditional statements and control structure. So the only difference between grade 5 and 6 is we're adding more control blocks. Okay, we're just making it more efficient and more, that's what the curriculum says. In grade 6, you want to have more efficient code with more conditional blocks, okay? So we've added the else block. If I look at my game and I start to play, click the green flag and be careful not to let the fish click the hook. I probably should have put in here, you need to hit the space bar to keep them from floating. So if I let go of the space, my fishy starts to move up. I've drawn a little makeshift hook here with art in Scratch. And what happens when I hit him? Game over. Let's take a look inside. What does this look like for coding? So first of all, let's talk about my fishy. The fishy has a concurrent code that it's going to go to the center of the screen for sure, and he's going to show himself. Okay, now let's stop it for a second. Forever, in a forever loop, yes, fishy dies. Forever loop. I've got 3 conditions here. If the space bar key is pressed, then change your y-axis by -10. You don't ever want to tell them to subtract 10. You're not minusing 10. You're always adding, always adding. So they're going to learn integers very early. Now you got to add -10, add -10. Okay, so if I hit the space, I'm adding a -10 to my y-axis, which means my fish is going up or down, and then the students will scream up, and you'll say, no, it's down. Whatever class you have. So that they have mixed. Okay, so now we've got else. Because before I said, hey, Iain, if your birthday was between January and March, stand up. And nothing happened. Because I didn't have an else. I had a true, but I didn't have a false. So let me try that again. Iain, if your birthday is between January and March, when I say go, if your birthday is between January and March, stand up. Else, tap your head. Can you say something, Iain? Because I actually lost your view.
You haven't said go yet.
Oh, okay. Now I can see you. Go. Okay, so there was an else. Something's going to happen. That's why right now, something's going to happen. If I click the flag and touch nothing, he dies. Because something's going to happen. In my grade 5 example, Stanley didn't move when nothing happened. It just stayed stagnant. It was only a true. Now we've thrown in a false, which is else right here. So if space is pressed, then change y by -10. Else, change y by 5, which means that if I hit my space bar, he goes down. Else, if I don't, he moves up. It's kind of important to talk about the numbers here. If I wanted to make that else change by y by -10, it's really going to be a funny race because he's going to go down, go up, go down, go up. A lot more difficult. Look at, he just plunks down to the ground because it just happened too fast. You want to give him a fighting chance. Don't make the number, oops a daisy, I've made too many changes. Don't make the numbers too different, my poor fishy. Okay, let me try that again.
Fishy dies again.
Go. Fishy dies again. But if I were to make that 10, I shouldn't have said -10. So
yeah, now you're
it just goes too fast. It goes too fast because you're going up and you're going down, you're going up and you're going down. So you can slow him down. And that's a question asked the students too. If I wanted to slow this fishy down, would I make my pixels less or more? Would I want him to go up by adding to the y by a little bit or by a lot? And if I want to slow him down, we're going to do it just by a little bit. So like this. Now, that's condition number 1. So we've got if and a false. That happens with the key being pressed. Now, there's something else too. Also, in a forever loop, if he's touching the hook. So this is this sprite here. So we've got another sensor. If fishy touches the hook, then hide the fishy. And we're going to switch the backdrop to game over. This backdrop over here, as you can see, if I click backdrops, I've added two. I've got an underwater and I've got a game over. And I've made that by just typing game over in a boardwalk backdrop. And the code for my backdrop is when the flag is clicked, go to underwater, because that's where I want it to start. It's my setup. This is the setup to my background code. I'm going to go back to fishy. And I'm going to see what happens when he touches the hook. He hides, we switch backdrop to game over, and we broadcast a message that's called hide the hook. If I click on hook, when I receive the message hide the hook, hide. Very self-explanatory. I've had to tell that when he touches that, I want him to go away. But when I restart my game, I want the hook to come back, so I need to tell him to show. Otherwise, he won't come back. So we're going to go boop, 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 game over. Boop, 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 game over. And that's grade 6, using more control structure blocks that are found in here, the if else. Grade 7, and I am going to zoom through a little bit. There are other parts of the presentation we won't be going into in detail, but they're available to you in the slides for you to explore later on. Grade 7, I've got 2 examples here, but I'm going to stick with the fishy example. I've taken my fishy game and I've brought it to a new level in grade 7. And if you're looking at this thinking there's no way I can code that, that's okay. Your students will, I promise. They have already started to code me only in a few months because they like it. So click the flag and use your spacebar right away. Fishy needs to avoid being caught by the hook. Be careful, the scuba guy is coming from the other direction. You'll lose points each time you hit scuba guy. Don't hit the bottom of the ocean floor. It's too dirty for the fishy. So we've got a few more elements in here. In grade 7, the students will be creating sub-programs and defined counts. Click on the backdrop to see the example of defined counts and click on scuba to see the sub-program. So I'm just going to play my game. As you can notice now, I've got elements coming on the vertical that I have to avoid. I've got a bottom of the floor. If you can see a blue line I've drawn. If I touch that blue line, it's a sprite, I'm going to die. And there's another blue line on the left. Bah, I died. There's another blue line on the left that when scuba guy hits it, he's actually going back to the other side. It's really just one scuba guy. And he's randomly coming in different spots and different times. There's a timer in my game and there's also a score. So this is getting a little bit more advanced. And if I take a look inside, what does that look like? Everyone's panicking. They're like, oh my God, that's so much. Don't worry about it. It's all repetitive. If we take a look, it's actually quite simple. So we've got when you go to 0, okay, we're going to set the size of the fish to 80%. So I've made him smaller in this game if you hadn't noticed. Then he's going to show forever. We're going to ask that same code we talked about earlier. When we touch the space, do this, okay? Nothing's changed. We've added another if. There's no false, it's just an if. If he touches scuba guy, change the score by -5. Ooh, we're losing points. And broadcast scuba guy restarts. If we touch the hook, we die. Okay, the game's over. If we touch the bottom of the edge now, it's the same code. It's the same code. We're just now using a different sprite called bottom of the edge, and the game is over. Over here, we've created Boolean expressions that are saying these operation blocks by saying if the timer is equal to a value of 50, then, so if true, change the score by 10 and set size to 90%. 1 second. What do you think? Why do you think every time 10 seconds has passed on the clock, we keep changing the size of the fish? What's happening to the fish every 10 seconds? It's getting harder to play. And why is it getting harder to play? The fish is getting bigger. The fish is getting bigger. And this is an element of video gaming that the kids are going to tell you. It has to start to get harder. Okay, what could we do to make it get harder? Well, maybe scuba could go faster. Maybe the hook starts to move. Maybe the fish changes size. There's all kinds of things that they're going to come up with and they'll make their own. Yep, less room to maneuver. You got it. So this is the same code. And if I click on the right, I can just duplicate. See? All I have to do is duplicate a code and change the data. This is the same code that repeats a bunch of times, and we only change the data. So I don't retake out each block and write the string of code that much. It's just, 30, 20, 10. So every 10 seconds, we've added 10 to the timer, or to the score, sorry, and added another 10% to the size of the fishy. Okay, that's what that looks like. Now, I'm going to go to the Scuba guide because we're talking about a subprogram. What does a subprogram look like? These blocks down here are called Scuba blocks. And again, this webinar is meant to just like awareness. You don't need to know this, and you just need to know where you have to go. So please don't think, oh my God, I'll never be able to remember all this. You don't have to. This is just to be aware of what this grade looks like. So we've got my blocks here, and I can make a block. A subprogram actually is a block, something that you create on the side that you're going to call on later. I like to call it phone a friend. So when you phone a friend, and so here's my main script here. When the flag is clicked, make Scuba guy appear. Because I'm using that several times in my code, I don't want to rewrite the exact same code every time. I've now created my own block as a subprogram. This subprogram will have defined a block and then called on it for our main script when we need it. So make Scuba guy appear, hide him, go to X coordinate here, and your Y coordinate is going to be a random location between 86 and negative 86. It can, and ask the students, well, where is that? It's about here, because the screen goes to 140, and that's something that they'll start to learn, the dimensions of the scratch screen. So we've got 86 is up here and negative 86 is down here. So Scuba guy is going to go anywhere in between here on the Y. Show, and then wait, and we're going to wait not just 1 second or 2 seconds, because the element of surprise in video gaming is so much more cool. So we're going to wait between 1 and 5 seconds. Okay, you can have them change it up and see what that looks like, maybe 1 and 10 seconds, but it might get kind of boring if Scuba doesn't appear. So when the flag is clicked, make Scuba guy appear, and forever, if Scuba guy is touching the left edge, make him appear again. So then he restarts here. So every time Scuba guy hits this blue line on the edge, which is this sprite, left edge I've called it, all it is a line. I've gone to a costume and I've drawn a blue line. That's it. That's my sprite. Okay. When Scuba guy touches it, he goes back over here. That's it. So that is a sub program that we find in grade 7, is creating those sub programs. Clicking over to grade 8, we're going to talk about those Boolean expressions that we mentioned earlier, and don't limit it to just grade 8. Start teaching them a lot sooner, because you're going to analyze data. So we're going to go back here, and the kids are going to solve problems, create computational representations, write and execute code, read and alter, change, blah, 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 describe and all that with analyzing data. So in grade 8, analysis of data, ask and wait sensors and Boolean expressions. What do those look like? Here we go. I'm going to bring this open, and now we've got an ask and wait block. How many sides does your shape have? We're going to create a shape. How many sides? Give me a random, what do you guys want? How many? 7. I'm going to hit 7 and enter. Ooh, I like your heptagons. Go ahead, pick another shape, and we're back. Now how many? Anybody? 5. I knew that. I knew it was going to be 5. Called it. I like your pentagons. Go ahead, pick another shape. Okay, so let's look inside here, because we're having ask and wait blocks, and we're having, 15? Sure, let me do 15 really quick. It's pretty. That's a lot of sides. Let's go inside and see what that looks like.
Quindecagon.
I know. Well, what is it?
Wait.
Quindecagon?
Yeah.
I didn't know
Quindecagon,
that.
yeah.
I was thinking decagon for 10, but I did not know that. Okay.
As long as you know your numbers in Greek, you're okay.
Okay, perfect. So I've made a sub program here, and these have little notes. And don't forget, you guys are going to have these examples, so you can go through this at your own pace. By defining a block, we're making a sub program. Yeah, we already talked about that. Okay. Define make shape, because I'm going to do that a few times. Hide, and then erase all, pen down, change pen color by 10. That's what made the rainbow, is that I didn't pick a color. I asked to change it by 10 each time it moves, which is cool. So now I've got in this sensing block, I've got an ask block. what's your name? How many sides does your shape have? I've written that in there. And then wait. Now, we've used the exact same code from grade 3 and grade 4, if you haven't noticed, okay? The only difference is this, and this is when it becomes super fun. This is the same code from grade 4. Instead of writing the number 3 or 4 or 5 or 6, I've said to put the answer. So she put 7. So then the answer here is 7, the answer is here 7. We're going to move 50 steps. We're going to change the pen color to make it pretty. And then this operating block is the best. If you go to the operating blocks and you plunk out a dividing block, you can take your shape that is 360 degrees in a circle and put your answer right here. So if I divide 360 degrees by 7, what it's going to do is going to make me turn in the appropriate degrees. Okay. Don't forget to do the same thing down here so your pentagons or heptagons don't stand on top of each other like the last time. Okay, so any type of number we put in here, it's going to somewhat have a response, and I'll show you what Stanley looks like in a second. Then at the end, okay, broadcast a message to Stanley. So that was my defined, I defined that block. So when the flag is clicked, make a shape, but also when I receive a message, pick again, make a shape, because it's going to go in a loop. Stanley, I'm going to open up. Okay, when I receive message from Stanley, this looks daunting and it's not. Okay, if the answer is less than 11, if true, so if it's true, and it's so which means less than 11, so 1 to 10, we're going to go to this block here. They have another conditional statement. If the answer equals 3, then say I like your triangles for 2 seconds. Okay, if it doesn't, if it's false, it's going to keep going. It's not 3, it's not 4, it's not 5, it's not 6, it's 7, it's this one. And then it escapes the loop and it goes down, broadcast, pick again. Once the condition is found true. So if the condition is found true at 10 and the answer was 10, it says I like your decagons, broadcast, pick again. But there is an else. If you notice, the else here says that's a lot of sides, because I didn't really want to keep going past 10. So when we did 15, we just said that and we broadcast to pick again. In grade 8, we are analyzing data, which means that we have to, it will have a response dependent on, every time might change. We're analyzing how many shapes? 7. Okay, so now we go into this side here and we're analyzing, is it 7 or is it no? Is it 7? No. Is it 7? No. Is it 7? No. Yes. That's what analyzing data is. We're analyzing a sensor or something that changes throughout the game. It will have a difference depending on what you put. And that is grade 8. Okay, let's move back on over to these slides. I know it's 5:14. Hear me out for another 4 minutes. That would be great. Okay. In these slides, I've provided you with ideas of unplugged coding activities, coding orally with pseudocode. We already talked about that. Using arrows and labyrinths. Read the code, project a code, ask them to say, what does that mean? What is that? Find what's missing, take out some of the data, and then they can, you can photocopy that and have them write it in. Match the game. Okay, so we've got this code equals that code equals this code. All 3 of these codes are equivalent. This is just more efficient, and this is its symbol. Challenge cards. Create some challenge cards. Make your shapes, and then they can pair up. You can put them in groups of 3 that way. In this slide, if you guys, when you get it and you click on link here, you're going to get Png blocks that are available to you to print and laminate and put magnets on the back, and you can put them on your whiteboard and slide them around, and then they can be dry erase and the kids can draw on them. So you can have centers with blocks that they can create their own codes and they can code their buddies, and that's super fun. Different types of plugged activities. Okay, debugging. Give your students a code that doesn't work on purpose, or have them make their own codes and give it to their buddies and have it not work on purpose. Okay, and then they have to find the bug and fix it. They are hitting every expectation by doing that. In here, a reconstruct code is giving them a code with the right blocks on the screen, but they have to put them together themselves, which is super fun. Okay, I'm not going to go through it because of the lack of time, but you have examples in this slide for each grade if you wanted to start off with, okay? And there's little notes that will help you move along, okay? Remixing, like we talked about earlier. So if you've got a program and you ask the students to remix something that happens already, again, don't ask them to just create right from the get-go because it's just a little daunting and overwhelming. Integration of coding, storytelling, science, religion, social studies, all of it. You can integrate coding into absolutely every subject that you have. Do animations, and they can record their voice too. If you need them to read something, maybe you have them read it in a code that they've made. And music and dance, absolutely. Collecting learning evidence through conversation, observation, and production. Here's different ways of gathering all that stuff. Talk to them. They will tell you. As soon as you say, what is that? You will be able to evaluate and assess what they know right through their conversation. This is just an example on how you would go in to create your own Scratch account, okay? Different platforms for different grades. Grade 1, we've got Scratch Junior, and the link is here, okay? Code.org and Codable. Grade 2, we've got Scratch, Code.org, and Code. And 3 through 8, adding Google CS first, which is a great, it's kind of like Google Classroom, and it adds different projects as you go. Which my son did it today in grade 6, and he was loving it. Create your own hero, and the teacher didn't have to learn it because it's self-guided. Make Code, which is an excellent bridge to start doing textual coding because there's tutorials and how to make Python and JavaScript coding with blocks as well. My students are doing those right now.
And there's the microbits.
Yes, the microbits are just awesome. Here are 2 resources. So the Scratch cards, these are golden. Okay, if you start giving them out challenges, it's something where they can start in a group and start to learn to code through Scratch cards, which is right back to the learning expectation of altering a code that exists. And then that's when they can start making their own by following the tutorials. That's where they would start to write. And of course, we've got a resource project. Iain and I are responsible for the coding lessons that you find on the OAME and FMO coding. We oversaw the team writing the codes, which are awesome. We got like 64, well, both languages lessons, 31.
And you should look at the other grades other than yours. So if you're from a higher grade, go back, take a look at the grade 1s because they've got a really, really good one about storytelling. Or the grade 2, 3, 4 all have different versions of how to dance. Or so like don't limit yourself just to your grade. Start Absolutely. There if you wish. But you can actually start with the grade 1 stuff if you're fairly new to coding and like go for it. And also though, all of them have an unplugged coding in there.
Definitely. I had to use my fast voice at the end.
Yes, and you still made it in under an hour and 20.
Robots. Oh, that is a completely different seminar because I am hands-on with Lego Spike Prime, EV3s, the Spheros, the microbits. That is a horse of a different color for another day.
Yes, yeah. There's also a really good what is it? 3D? Oh, Inksmith. Sorry, inksmith.com. I'll put that in now. So yep. They have Climate Action Kit is amazing, and they have complete lessons for every single thing that they sell.
So I'm on the Inksmith Creative Committee right now, and there's lots of things that are in the works with Inksmith that'll be coming soon.
Yeah, so that's a really good comment, Leanne, that your son took all the computer science in high school and loved them so much he's taking it in university. That's what we want to be able to get to the elementary students so that they will take those coding courses in high school. They'll actually know what it's about.
Definitely. And don't get overwhelmed by this. This was a lot. You don't need to know it all today.
Oh heck no. And it's really, really important that you know that you can actually do this alongside your students. So you can take that any of these lessons that are on the infographic and you can do it right alongside your students and tell them, hey, we are going to learn together. And that's how I started when I first did it with my grade 7 and 8s. And it's really a powerful thing for your class community to be a fellow learner.
Thank you guys. I've got some good feedback in the chat. Michelle, should we hand it over to you?
Okay, perfect. You know, we did it in terms of timing. We are just 5 minutes over, which is really, really not bad at all. And absolutely fantastic presentation. We loved it. I think I loved it. I think we all loved it, and we learned a ton of things in just 1 hour, which is unbelievable. And also, I love how you guys complement each other. Really great teamwork, with Iain doing a lot of the legwork in the chat box, exactly, with his magic fingers, or his old fingers, as he said. And I also love how your voice complement each other, because Amanda has a very upbeat voice. She calls it her fast voice, but it wasn't that fast, actually. It was really upbeat. And then Iain has a very calming voice, and it makes it for a very good experience. And
so
actually,
I tell you, we got to start a radio show, Amanda.
Exactly, that's what I said, Iain. You should, exactly what I was going to say, Iain. You should host a jazz program, a late night jazz program on CBC. I would see you in that job perfectly.
Yeah, and Amanda can play.
Amanda needs to practice.
Yeah, Iain does too.
Iain's voice is perfect, and Amanda as well. But very,
I like that.
nice,
Tech talk with Amanda and Iain.
I just want also to, guys, don't leave yet. I just want you to stay in the class for a few more minutes. I just want to say thank you again. We learned a lot. We learned how creative coding really is. I've met a few programmers in my life, and I was always amazed how creative they were. And many of them were actually musicians. So I kind of detect a pattern there. And as Iain said, coding is art. And I think that's what we learned today, is that coding is art. I want to thank you all for your participation. It's always great when experienced teachers are helping newcomers in the field. And I could see all of you answering questions in the chat box throughout the presentation. So that was really fantastic, and I enjoyed it. So I'm just going to share my screen for a quick second. If you can bear with me for a second. I just want to show you something. Okay, do you see my screen? I guess you should see it right now. I just want to let you know that we have I want to thank you. First of all, I just want to let you know that you're going to get a survey tomorrow, a quick survey, and I would like you to take the time to fill it up for us. It helps us to improve our sessions. And you will also receive a copy of the recording, all the slides that Amanda has prepared, and also all the links will be shared with you guys. And we have more of these fantastic webinars. So this is number 2. So I really want you guys to keep your Thursdays open if you can. They are all scheduled on Thursdays afternoon at 4 p.m. And we still have 4 to go. This is number 2. So on May 6th, we have addressing the data analysis expectation using Google Colab to analyze and graph your data with Peter Bean and Grant Hutchinson. Then on May 13 and May 20, we have student-centered to K8 culturally responsive coding experience with Melanie Mulcaster, Amanda Williams, and Michelle Peter Adams. And then on May 27, we have integrating Minecraft and Make Code Called Builder in your math program with Andy Forgrave. So sorry for talking very fast, but I know that you guys all want to go back to your lives and to your kids and to your families. I will just invite you to go to the OTF calendar, and then from the OTF calendar, you will be able to register yourself for the next 4 upcoming sessions. And that's it. I just want to say thanks again to Amanda and to Iain for this fantastic session. And I hope to see you again next week.
Thank you.
Yeah.
Thanks to everybody. Have a great night.
Yeah. Thank you all. Thanks so much for this fantastic webinar, Amanda and Iain. It was really great. And I hope that I'll work with you guys again in the future. And thanks to everybody. I'm going to stop the recording now. Thanks so much.